Look up at the night sky. The familiar, cratered surface of our moon has hung there quietly for billions of years, providing a peaceful, stable backdrop for our planet. But imagine it suddenly vanishes. In its place, bursting into view and dwarfing the city skyline, is Saturn. The sheer beauty of it would be staggering. You'd see intricate, multi-layered patterns of ice and rock stretching entirely across the heavens. It would completely dominate our view because Saturn is the second largest planet in our solar system. This diagram shows exactly how immense that difference in scale is. Our moon shrinks down to a speck as Saturn's profile expands, proving to be nearly 120 times wider than our original lunar neighbor. This aesthetic upgrade to the night sky creates a ticking gravitational bomb, forcing Earth into an extreme planetary stress test. Let's set the exact parameters for this celestial lab experiment. We are placing Saturn at the precise distance from Earth that the moon used to occupy. Gravitational pull depends entirely on mass. Between any two orbiting bodies, there is a shared center of mass they both orbit around, a balancing point known as the barycenter. This graph maps the mass shift. Earth's gravity well easily contains the moon, but when Saturn drops in, it instantly dwarfs our planet's influence. The barycenter violently shifts. Earth no longer anchors its orbit. Its field lines bend, distorted toward the gas giant. In this new setup, Earth surrenders its status as the center of its own local space and becomes a tiny hostage to Saturn. Down on the surface, the physical toll begins immediately. Our deep blue oceans are the primary target of this gravitational disruption. The extreme new pull grabs onto that water, multiplying our normal tidal forces and creating unimaginably tall, fast-moving waves that surge over the coastlines. The atmosphere follows right behind. The gravity distorts our cloud cover, ripping regular weather patterns into chaos and whipping up extreme storms. While the physical world breaks down, humanity's immediate response would be to point every massive scientific telescope straight up to study the phenomenon. But that data collection would be incredibly short-lived. The intense gravity is actively throwing Earth's rotation entirely off its axis, eliminating any stable ground to observe from. Earth's biosphere operates as a finely tuned machine. Forcing a massive gravitational variable into the equation acts as a wrench in the gears, triggering a total systemic collapse. In reality, Saturn could never occupy the moon's orbit. At this proximity, Saturn's gravity exerts such violent force that it would exceed Earth's structural integrity, shattering the planet's crust, or flinging us out of the habitable zone entirely. This scenario visualizes the invisible mechanics of gravity, demonstrating how mass and distance dictate the stability of every system on Earth. The moon we actually have is exactly massive enough to steady Earth's axial tilt, keeping our seasons predictable without the destructive pull we just witnessed. It occupies the gravitational sweet spot required for a stable biosphere. This logic extends to the rest of the solar system. Large bodies like Saturn belong exactly where they are, floating in their own isolated, distant orbits, to maintain the architecture of our cosmic neighborhood. The beauty of the cosmos is found in these quiet, balanced gravitational mechanics that allow life on our planet to thrive. But if Saturn did magically appear in our sky tonight, what do you think would be the very first warning sign? Let us know in the comments and subscribe for more experiments that break the universe to see how it works.